Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about instruction pipelining. So, instruction pipelining is an reads consecutive instructions from memory while previous instructions are being executed in other segments. This causes the instruction fetch and execute phases to overlap and perform simultaneous operations. If a branch out of sequence occurs, the pipeline must be emptied and all the instructions that have been read from memory after branch instruction must be discarded. So, in that instruction pipeline, it is one type of pipelining. So, there are so many types of pipelinings are there. Arithmetic pipelining, instruction pipelining, and parallel pipelining. So, today we are discussing about instruction pipelining. So, if I am taking A plus B into C plus D. So, A plus B and C plus D. How many operations are there? Means here 2 operations. Suppose A plus B output is X. C plus D the output is Y. Example. So, we have to perform X into Y. So, after getting the output of A plus B and after getting the output of C plus D, then only we have to perform multiplication. So, how many operations are performing here means A plus B is 1 operation, C plus D and 3. So, how many operands means 3 operands are there. So, we have to go for the program as a 3 operands. So, when A plus B and C plus D, we have to go parallelly. Is it possible? Yes, it is possible. Why? Because A plus B is separate operation and C plus D is another operation. So, after getting the output result, then only we have to go for the multiplication. So, when I am going for the multiplication of this one, first A plus B, after then C plus D. So, we can perform A plus D and C plus D parallelly. Then we will get the answer parallelly. So, after getting the value of A plus B and C plus D, then we have to go for the multiplication. So, this after this planning, how we are doing this operation is calling as a pipelining. So, what is the process we are going on? What is the procedure we are going for the program? So, I'm calling as it is one program. So, how we are planning? It is one program. So, how we are planning to execute this one? That is important. So, it is a process of getting the output. That is a pipelining. Pipelining is a process. Okay. So, here it is. I am going for the instruction. Suppose arithmetic A plus B. How many instructions you are using for the pipelining? How many instructions you need to complete the one program? So, that is important. So, an instruction pipeline reads consecutive instructions from memory while previous instructions are being executed in other segments. This causes the instruction fetch and execute phases to overlap and perform simultaneous operations. So, when I'm going for the instruction, already we know that in the pipeline we are going for the fetch. First we are fetching, after then decoding, after then we are going for the executing. So, fetching, decoding and executing. So, these are the pipelining process. So, in the cause of instruction, fetch, execute phases to overlap and perform simultaneous operations. So, fetching, decoding and executing these phases to overlap and perform simultaneous operations. So, we are going for the simultaneous operations of this one. And if a branch out of sequence occurs, the pipeline must be emptied and all the instructions that have been read from memory after the branch instruction must be discarded. So, when I am going for the instruction, suppose I am going for the addition of 2 numbers A plus B, after then addition of 2 numbers C plus D. So, these all instructions that have been read from memory after the branch instruction must be discarded. And consider a computer with an instruction fetch unit and an instruction execution unit forming a 2-segment pipeline. Suppose I am going for the instruction fetch unit and instruction execute unit. So, when I am going for the fetch operation, this fetch I am going for the in the terms of instruction fetch, instruction decode and instruction execution. So, there are 2 to 3 stages are there. So, these instructions have been read from memory. After the branch instruction must be discarded, and a computer with an instruction fetch unit and an instruction unit forming a two-segment pipeline. So fetching and executing. So we are taking as a two-segment pipeline. It is one segment, another. It is a two-segment pipeline. Why I am going for the two-segment pipeline means fetching is one process and executing is another process. So it is a two-segment pipelining. Okay. So it is a FIFO buffer can be used for fetch segment. First in, first out process that can be used in the fetch segment. So the processor fetches an instruction from the memory, decode the instruction, and determine the kind of operation that has to be performed. So the processor first fetches the instruction. What is, so I am giving instruction 1, arithmetic operation, add ax comma bx. Okay, this instruction first we are fetching from the memory and decode the instruction and determine the kind of operation that has to be performed. First to go for the fetch, after then we are going for the decoding. So fetching is completed from memory, after then we are going for the decoding of this one. After completion of decoding, we are going for the execution. If anything problem in the fetching or in the decoding, it will be can't execute this one. And the processor is trying to fetch from the memory of the particular instruction of the in the memory, and after fetching this instruction from the memory, it will be decode the instruction and operation should be complete. When fetching and decoding is completed, then only it is going to be execution. So okay, that is called, it is a performed. The operation should be performed. The operation requires operands, then the processor fetches the operands from the memory and then perform the required operation. Finally, the processor stores the result to the specified memory location. So if I am going for the add ax comma bx, mul ax comma bx. So how we are doing? So it is one instruction, it is another instruction. So when I am going for the a plus b, I need one arithmetic operation and c plus d. So if a plus b, I need one instruction, c plus d, I need one other instruction. For a multiplication, we need another instruction. So how many instructions I need? Total 3 instructions. So these operand, it is completely operation and it is called operand. What is operand here means add. What is operand here? Mul. So a plus b, what is operand I need? Addition. C plus d, what is operand I need? Addition. Add. So after completion of result, I need multiplication, means which operand we need means mul, mul. So the operation requires operands, then the processor fetches the operands from the memory and then perform the required operation. Finally, the processor stores the result to the specified memory location. When operation requires the operands, so all operands are available. Why? Because processor fetched from the memory of related operands and the memory of the perform required operation, the processor stores the result, means fetching is completed, decoding is completed, execution is completed. So what is the final answer after the executing? What is the result of executing this one? So that result to be specified in a memory location. In this way, the processor processes each instruction from the start till it finishes execution, and then it fetches the next instruction for instruction. Now we can divide these instruction execution into stages, that it could be divided into instruction fetches, instruction decoding, and operand fetch, instruction execution, operand store. So these are the stages for instruction. So first, processor process the each instruction, add ax comma bx. So it start and finish the execution, means first instruction is available now. So what we have to do? First go for the fetch, decode, execute. So fetching, decoding and executing. So instruction is available from the memory and it will be finishing the execution. After the availability of this one, the next instruction should be instruction. So after the execution, it will go for the first instruction is completed. Next to go for the second instruction. Why? Because first instruction fetching completed, decoding completed, execution completed. Next to go for the next instruction and going for the fetch. So like this. So these instruction execution into the stages could be divided into how many stages are there to confirming from fetch to execution. First, instruction fetches. Fetch the instruction from the main memory or cache. So suppose I wrote add ax comma bx. So where is this one? Where is the memory location is there? That is in the main memory or cache memory. Okay. Instruction fetches means fetch the instruction from the main memory or cache memory. So after fetching is completed, then it is going for the decode. Yes, in the memory our instruction is available. Then what is the next step? It is going for the decoding. So instruction decoding. The processor interprets instruction and determines the operation that has to be performed. So processor instruction is available now. So what we have to do? Decoding means our low level language is converting to the machine level language. So microprocessor instructions are always in the low level language. These are converting to the machine level language. We are converting to the decode operation. So this processor interprets the instruction and determines the operation that has to be performed. And operand fetch. If the execution of the instruction requires operand, then operand is available. Then the processor fetches operand from the main memory or cache memory. So operand fetch. So where is the operand? Add, mul, div. So is it suitable for this one? If I am going for the a plus b. So is it suitable? This operand is suitable? Yes. After the operand is available, we are going for the how many registers we need for the operand. Suppose I need 2 registers. So we are going for the 2 registers a comma b with add operation. Okay. Operand fetch. If the execution of the instruction requires the operand, then the processor fetches operand from the main memory or cache memory. Instruction execution. The processor performs the desired operation. So after fetching is completed, decoding is completed, next operand fetch. So after then instruction execution. So fetching is completed, decoding is completed. What is the next? We are going for the finally execution. So instruction execution. So what is the instruction and why and what is the execution of the result? So the processor performs the desired operation. So add x comma bx. We are going fetching is completed and this is converted to the decoded and we are going for the execution. Means what is execution now? Arithmetic mean add means we are adding 2 numbers. That is I need 2 registers. Suppose after the execution it will ask what is the value of A and what is the value of B. We have to enter these values, then we will get the answer of the 2 registers or 2 values. So instruction execution means the processor performs the desired operation and operand store. The result of execution is stored. The result of execution is stored in the operand store. So it is an instruction cycle. What is the first one? Instruction fetch, instruction decode, operand fetch, execution and write back. After the execution, write back means it is going to the next instruction. It is also called ready for next instruction. So instruction fetching. Suppose I am going for move ax comma bx. So this instruction is fetching from memory. First step, fetching from memory. Second step, after this one, it is going for the decoding. Okay, decode the instruction. Third one, operand fetch. So which operand is suitable for this one? Okay, like this. Okay, next operand is completed. Fourth one, execution means getting the result in the execution process. Write back means the result will be showing in the display or next instruction is ready for this. So okay, so instruction cycle is first stage instruction fetch, second stage instruction decode, third stage operand fetch, fourth one execution and fifth one write back means going for the next or it is showing a result in the back operation. fetch, decode, operand decode, execution, it is a write back. So instruction pipeline. Thus, an instruction stream can be placed in a queue waiting for decoding and processing by the execution segment. This reduces the average access time to memory for reading instructions. Whenever there is space in the buffer, the control unit initiates the next instruction fetch phase. So, first instruction stream can be placed in a queue waiting for decoding and processing by the execution segment. So, first one already we discussed in the instruction fetching. So, in the instruction stream can be placed in a queue. So, already we discussed in a queue means first in, first out process. So, then maybe we have to go for the queue also. And waiting for decoding and processing. So, instruction fetching is completed. Then only we are going for the decoding process. Maybe it will be waiting time or it is in the queue. And after the completion of queue, then we are going for the decoding, then going for the execution of the segment. And this reduces the average access time to memory for reading instructions. Okay, when I am going for the queue, first in first out service, the average access time of the memory reading maybe reduces, and whenever there is a space in the buffer, the control unit initiates the next instruction fetch phase. So whenever there is space in the buffer means loading all the instructions to execute, and the control unit initiates the next instruction fetch phase. That means write back to that one. That is a fifth stage of this. So the following steps are needed to process each instruction. Fetch the instruction from memory, decode the instruction, calculate the effective address, fetch the operand from memory, execute the instruction, stores the result in the proper place, and these pipeline may not perform at its maximum rate due to different segments taking different times to operate, and some segments being skipped for certain operations, memory access conflict. So it is a flow chart of instruction pipeline, how starting to ending, what is the process is going on step by step on each stage. So first fetch the instruction from memory. So already we given some instructions to the processor. So the processor fetching the instruction from main memory or cache memory. So after fetching that one, so fetching, decoding this one, and calculate the effective address, and fetch the operand from the memory, execute the instruction, store the result. So here we are going for first segment. What is that means? Fetch the instruction from memory. Then segment 2, decoding. After fetching this one from the memory, we are going for the decode instruction and calculate effective address. So if calculating the effective address, if is it any branch we need, then yes means we are going to the update the PC and empty the pipeline and going for the again going to the branch. If there is no branch means fetch operand from memory, execute instruction, and if there is interrupt, yes means interrupt handling and go to this update PC and empty pipe. If there is no interrupt means we are executing and again going back to the fetch instruction. So in the segment 1, first one is a fetching, segment 2 decoding. If any branch conditions are there, any branch will be there in the loop, then it is going to the, if S means it is not going to the segment 3, segment 4, directly it is going to the update PC and empty pipeline and again going to the branch condition. If there is a branch means then going to the fetch operand. What is the operand here and what is the operators, and fetch operand from memory. How many operands you are using in the instruction or in the operation in the program. And after the fetching this operand, we are going for the execution of the instruction. If there is any interrupt will be there, it is going to interrupt handling. Which type of interrupt is there, and we are giving the priority for this interrupt. If I am going for the priority, then INT 0 or INT 1 or INT 2 or INT 3. Which interrupt we have to give to the this instruction. So we are starting from interrupt 0 means highest priority, that is called a trap. What is the highest priority of the interrupt? That is called trap. So what is the interrupt we need, what is the priority of this one? Depends on your priority, it will be giving the what is the stage of interrupt. Interrupt 0, interrupt 1, interrupt 2, interrupt 3. Highest priority is the interrupt 0 and the lowest priority is the interrupt 3. So which priority you have to give to the current going on of this program. Okay, this program is going on. What is the program means? Addition of two numbers, suppose. Okay, so we are not executed. Why? Because the interrupt signal is came to this one. Then if interrupt is there, then going for the interrupt handling. If there is no interrupt means we are going for the again going to the fetch means next operation is going on. So interrupt handling and update PC and empty pipeline. Okay, it is a process of instruction pipeline. It is a 4 segment instruction. Segment 1 fetching, segment 2 decoding, segment 3 fetch operand, segment 4 execution of this instruction. So this pipeline may not perform at its maximum rate due to different segments taking different times to operate and some segments being skipped for certain operations of memory access conflicts. So example, I am taking 4 segment instruction pipeline. Assume that decoding can be combined with calculating the EA is 1 segment. Okay, enable accumulator, and assume that most of the instructions store the result in a register so that the execution and storing the result can be combined in 1 segment. When it is going for the accumulator, while an instruction is being executed in segment 4, the next instruction in sequence is busy with fetching of operation from memory in segment 3. The effective address may be calculated in a separate arithmetic circuit for the third instruction, and whenever the memory is available, the fourth and all subsequent instructions can be fetched and placed in an instruction of FIFO, first in first out. Up to 4 sub operations in the instruction cycle can overlap, and up to 4 different instructions can be in progress of being processed at the same time. So when I'm going with the 4 segment operation, what is the first segment means? Fetching. Second one, decoding. When I'm going for the 4th segment, when instruction is being executed in the segment 4, the next instruction is subsequent is busy with fetching of operand from memory 3 in fetching in the segment 3. So segment 4 is going on while the next instruction is fetching the operand from the memory of segment 3, and the effective address of the segment 3, the effective address may be calculated in a separate arithmetic circuit for the third instruction. Okay, and whenever the memory is available, the fourth and the final subsequent instructions can be fetched and placed in instruction in a FIFO process, first in first out process. So when instruction cycle means fetching, decoding, executing, all this can be overlap, and up to 4 different instructions can be progressed and being processed at the same time it is possible. And the following figure shows the operation of the instruction pipeline. The 4 segments are represented in the diagram as abbreviated in the symbol. First one, FI, fetch an instruction from memory. DA, decode the instruction and calculate the effective address. FO, fetch the operand. EX, execute the operation and store the result in the proper place. So how many are there means? 4 segments. Segment 1, fetch an instruction. Fetch an instruction. Next, segment 2. What is it means? We are decoding the instruction and calculate the effective address. Segment 3. What is segment 3? We are fetching the operand. We are fetching the operand. FO, fetch fetch an operand. Next, segment 4. We are execute the operation of store the result in a proper place. Here execution. So in the first instruction 1, first time you give the instruction 1, any of the instruction. First step is one FI means fetching. Second cycle it is going for the DA means decoding. After then going for the fetch the operand and execution. Okay, it is the first cycle, first clock pulse example, second clock pulse, third clock pulse, fourth clock pulse. Okay, so first stage, second, third, fourth is completed. So when it is coming to the first stage to second stage, what is the role of this fetch? Now fetch is empty. Why? Because instruction 1 is fetched. So in this stage, fetch FI is completed. Then now it is free now. So I am using for instruction 2. Okay. So instruction 2 is starting from second cycle, second type pulse. Why? Because in the first clock pulse, FI is going on. In the second clock pulse, DA is going on. So when I am going for the second stage or second clock pulse, first is completed now, FI is completed. Then it is now free. This FI is now free. I am using for second one. Okay, 1, 2, 3, 4 now. So when it is converting to FI to DA. Okay, now in DA now, so FI is free now. So I am starting from FI in the third clock pulse. So okay, here instruction is going for the fourth clock pulse. Like this I am using like this. It is like a step. So first clock pulse, first instruction is completed. Next instruction 2. Now first clock pulse is now free now. So second I am using for FI of second instruction. When I am going for the second clock pulse, second, then I am going for the third I am going on. So second is going on. Next third is started at third stage, fourth, fifth, like this. Okay, it is like some step. So we are using like this. So reasons for pipelining to deviate from its normal operations. So what are the reasons? First one is a resource conflict caused by access to memory by two segments at the same time. Most of these instructions can be resolved by using separate instruction and data memories. Okay, so multiple segments. Here I am using 4 segments. Suppose I am taking for the in a memory 2 segments at the same time. Most of these instructions can be resolved by using separate instructions and data memory. Sometimes at a time multiple instructions can be executed. So for these conditions I am aiming for the resource conflicts. And the data dependency conflicts arise when an instruction depends on the result of a previous instruction, but this result not yet available. Okay, so present, what is that one, and then what is the next? So some instructions depends on the result of a previous instruction, but this result is not yet available. Suppose I am going for the A plus B into C. Suppose, so if I want to go for the multiplication with C, definitely I need A plus B result. If I know the A plus B result, then only I will go for the multiplication with C. If A plus B result is not yet completed, then this multiplication is waiting for A plus B result. Like this, instruction is depends on, suppose I am taking, what is instruction is the result of A plus B. That means suppose I am taking D, result of A plus B equal to D. So I am multiplying with D into C, example, or X into D. So this instruction depends on the result of previous instruction. This multiplication is depends on previous addition of the result. Then it will be complete. Otherwise, it not yet complete or it not yet available to the result. And branch difficulties conflicts arise from program control instructions that may change the value of PC. So these are about the instructions. Okay. So today we discussed instruction pipeline. How many stages of this one? So in the instruction pipeline, we are going for the 2 segments, 3 segment, 4 segment, and it is going on as a FIFO process, first in, first out process. And what are the stages are there? Instruction fetch, instruction decode, and operand fetch, instruction execution, operand store. Instruction fetch, instruction decode, operand fetch, and execution. 4 stages are there. 5th one is going for the write back, means we are going the result is going result should be shown in that program, or it write back to the or next instruction is ready for that one. And thus the instruction stream can be placed in a queue. first in first out process. And these are the following steps to needed to process each instruction. Fetch the instruction from memory, decode the instruction, calculate the effective address, that is the EA, and fetch the operand from memory, execute the instruction, store the result in the proper place. So it is a flow diagram or flow chart of the instruction pipeline. First one is fetch instruction from memory. It is a segment 1, and decode the instruction segment 2. If branch is needed, then it is going to the update PC and empty pipe. If no need of any branch, then fetch operand in segment 3 and execute in the segment 4, and it is going to the interrupt. Is interrupt yes means it is going to the priority of interrupt and interrupt handling, update PC and execute or empty pipeline. If interrupt is no need, then it is going to the again to the next instruction. It is about the instruction pipeline with 4 segment instruction pipeline. It is the shows the operation that the instruction pipeline of 4 segments are presented in the diagram. Okay, fetch an instruction F5. Second stage, decode the instruction with effective address, and FO, fetch the operand, EX, execute the operation and store the result in the proper place. So these are the 4 segments, F5, DA, FO and EX. So these are the reasons for deviating the normal operation in the pipeline. Resource conflicts, data dependency conflicts, branch difficulties conflicts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.